Hey everyone, it's Miss Butler. I have a video on counting atoms for you. So the goal is to be able to use any subscripts, parentheses, coefficients to correctly count the number of each element in a formula. And the ultimate goal is that we can count correctly so that we can balance equations. How many of carbon are on the left side of the arrow, how many of carbon are on the right side of the reaction arrow, and that will help us when we start balancing. So first, let's do some vocab. I'm going to use the word coefficient to talk about any big numbers in front of a chemical formula. So what this big 3 means as a coefficient is that I have 3 of this CO2 molecule. So a coefficient is the big number. It tells you how many of that entire molecule there are. Whereas a subscript is referring to the little numbers within a formula. So in this CO2 molecule, there are 2 oxygens. So the subscript tells me how many of each element I have. The coefficient, the big number in front, tells me how many of that whole chemical exists. So there are some rules for counting atoms. The first rule is that subscripts refer to the atom they are behind. So for example, H2S, that 2 is referring to hydrogen. There are 2 hydrogens and 1 sulfur. Overall, there are 3 total atoms in this chemical, 2 hydrogen and 1 sulfur. The second rule is that coefficients apply to the entire compound. So we'll multiply the coefficient and the subscript. So 3H2S means there's 3 times 2 hydrogen and there's 3 times 1 sulfur. So 3 sulfur and 6 hydrogen add together to give us 9 total atoms. But we apply that 3 to the entire chemical. And the last rule, if an element or a compound or a part of a chemical are in parentheses, that subscripts behind the parentheses applies to everything inside. So barium is not in the parentheses, so there's just 1 barium. Oxygen and hydrogen are both in the parentheses, so there's 2 times 1 oxygen, 2, and 2 times 1 hydrogen. So that 2 outside the parentheses applies to both the oxygen and the hydrogen. When we add those together, we get 5 total atoms in this chemical: 1 barium, 2 oxygen, and 2 hydrogen. Now I'd like you to pause the video and try these 3 examples. I want you to count up and tell me how many of each atom there are and then what the total number of atoms is. All right, CaCl2. I see 1 calcium. I see 2 chlorines, so 1 and 2, and we add those together to get 3 total atoms. That one was way too easy. Let's try this one. Zinc, not in the parentheses, so there's 1 zinc. Nitrogen gets this 2 from the parentheses, so 2 times 1 gives me the 2. This 2 also applies to oxygen. 3 times 2 is 6. When I add those together, 1 plus 2 plus 3, that gives me 9 total atoms. And last but not least, we have magnesium, we have nitrogen, and we have oxygen, and we have this big old 3 in front. Here's my advice. I'm actually going to ignore this 3 until the very end. So magnesium, without looking at the 3, I just have 1 magnesium. The nitrogen, there are now 2 nitrogens, 1 times 2, and my oxygen, 2 times 3, gives me 6. Now we know that this coefficient that I tried to erase, maybe not. Okay, we'll just leave that there, I guess. Try this. That 3 in front applies to the whole chemical because I have 3 of this entire chemical. So now at the very end, what I'm going to do is I'm going to multiply each of these by 3. 1 times 3 is 3. 2 times 3 is 6. 6 times 3 is 18. Okay, that's how I got these final answers right here. Then at the very end, I want the total, so I'm going to add those together. 3 plus 6 plus 18 gives me 27 total. So remember, coefficients apply to the entire chemical. I think it's easiest to count it normally, and then at the end, multiply everything by that coefficient in front. Hopefully this helps.